Hey guys, in this video I am going to discuss what do physicists mean when they talk about spin in quantum mechanics. My name is Saptarshi and you are watching Cosmos Unveiled. Quantum mechanical spin is basically intrinsic angular momentum which every elementary and composite particle possesses. There are two terms to be explained. First, intrinsic. Intrinsic property is a property which the object referred to possesses by itself. It is inherent, whereas an extrinsic property is something which is not inherent. For instance, mass is an intrinsic property, whereas weight is an extrinsic property. Just like mass, charge and spin are also intrinsic properties. Second term to explain is angular momentum. So, what is momentum? By the term momentum, we simply mean linear momentum, which is something an object possesses when it moves along a straight line. Linear momentum equals mass times velocity, or simply P equals mv. The thing that is to be noted here that there are arrows on P and V that signify that they are vectors. And the direction of P or momentum is in the direction of velocity V. So now let's come to angular momentum. Angular momentum is something which an object possesses when it spins around its axis or rotates around any object. Angular momentum equals mass times tangential velocity times radius of rotation, or simply L equals mvr. It is the scalar formula of angular momentum, but it is not the actual formula to derive angular momentum. The one which you see in the screen right now is the actual formula. It is the cross product of the r vector and the p vector, which is basically the radius vector and the momentum vector. For those who don't know what a cross product is, I will leave some material in the description below. But the craziest thing about quantum mechanics is that some particles seem to possess inherent angular momentum. It is not caused by the particle spinning on its own axis. It seems as if they are spinning, and that is why the name spin. This so-called intrinsic angular momentum or spin creates an intrinsic or inherent magnetic field around any charged particle like electron, and the intrinsic magnetic moment is created as if the particle is actually spinning. Just like when a charge revolves in a circle, it creates a magnetic field like a bar magnet. So quantum mechanical spin basically causes charged particles to be tiny bar magnets. And quantum mechanical spin is also the root of magnetism in matter. But how do we know about spin in the first place? Well, it was first detected in an experiment called the Stern-Gerlach experiment in the year 1922. I would highly recommend to check out that experiment once you finish watching this video. I will leave some resources in the description below. But where does this so-called quantum mechanical spin come from? Well, it was first predicted by the British physicist Paul Dirac when he combined quantum mechanics with special relativity and gave us the famous Dirac equation. I will surely make a video on this topic later. Now let's come to quantization of spin. Yeah, you heard it right, spin is also quantized in quantum mechanics. The so-called spin or intrinsic angular momentum can take only certain allowed values, which are either integral multiples or half integral multiples of the reduced Planck constant, which is denoted by h bar. As I discussed in my previous video, the particles with half integral spin are called fermions and the particles with integral spin are called bosons. But how many spin values can a particle take? Say a particle is a spin n particle, where n denotes the maximum multiple of h bar which the particle spin can take. Now keep reducing ones from n until you reach negative n. Now count the number of spin value it takes. For example, say a particle is a spin 1 particle, so the number of spin values it can take is 1, 0 and minus 1 times h bar. But say a particle is a spin 3 by 2 particle, then the spin values it can take are 3 over 2, 1 over 2, minus 1 over 2 and minus 3 over 2 times h bar. So this was the basic description of spin in quantum mechanics. Thanks for watching, see you in my next video.